Hello everyone, let's have some exercises on how to use infix expressions to show primitive stack operations. Okay, so before that, we'll have some expressions here. Okay, so I'll be showing this to you. Number 1, number 2, number 3. So those are the expressions that we'll be going to evaluate, convert to postfix, and also to show the primitive stack operations. Okay, so let's start with number 1. Number 1, so first on the given and also in the requirement, so they should have to evaluate the infix expression. Okay, so using the rules of precedence. So as you can see here, the greater than and equal symbol is the last operator that we'll be going to evaluate because for the reason that this is the lowest order of precedence. Okay, so next we will have to evaluate on the left side and also on the right side of this expression. Okay, so on the left side we have the asterisk symbol because this is the next lower order of precedence. Okay, on the right side is the division symbol. It's also in the lowest order of precedence or the highest order of precedence. Okay, based on these expressions, but we'll be evaluating this from left to right. Okay, so we have here 2 times 3, then we have 10 divided by 2. Okay, so the answer is 6. Then here the answer is 5. Okay, so next well, we have to evaluate also on the left side and on the right side. Okay, so what will happen is we have to evaluate this and we have to evaluate this also. Okay, 5 minus 6, we have negative 1. Then 5 plus 12 is 17. Okay, so next, so we have negative 1 and we have 17. So all you have to do is check if negative 1 is greater than or equal to 17. If it is, then this is, or the answer should be true. But if not, so the answer is false because negative 1 is less than, not greater than. So the answer is false or 0. Okay? Okay, so now we have convert infix expression to postfix expression and evaluate it. Get the result. Okay, so we have the value or the expression given above. So all you have to do is convert to postfix. Okay, and the postfix expression we have 5 minus 2 times 3 greater than or equal 10 divided by 2 plus 12. So now all we have to do is we have to evaluate this using or convert this expression to postfix expression. Okay, so we have first, based on the rules of precedence, okay, we have to convert this by using the rules of precedence. Like here, multiplication, division would be evaluated at first. Okay, then we have to move. No, in your previous topic, we move the operator to the right if it is postfixed. We move the operator to the right. Like we have here 2 times 3. So meaning the operator asterisk or multiplication times. So will be moved to the right. Okay. And the division symbol will also be moved to the right of 2. Okay. So that is the answer. Okay. Next is we have to check. Okay, the next operator that we will be going to evaluate. Okay, so we will be moving this operator, the minus symbol, to the right of the asterisk and the plus symbol to the right of the 12. Okay, so the answer is okay. So next we have last operator greater than equal. So as you have noticed last time in our previous example or in our previous discussion on the infix notations and also in the postfix notations. So we try to move the operator the greater than equal operator or any other operator here on the rightmost portion if, for example, the expression on the right was or is already evaluated. Okay, so we'll be moving this to the right. Okay, so our final answer is this one. Okay, so we have now the postfix. So all you have to do is evaluate. Okay, using the postfix expression. Okay, on the postfix expressions or notation, so we'll be evaluating it. Okay, so first, so we have 2 times 3. The next, we have the minus. Okay, because this is postfix, so we'll be evaluating it from left to right. Okay, -1. Okay, then next operator is the division symbol. So 10 divided by 2, so that will be 5. Okay, so next we have the plus symbol. So plus, so you have to add 5 plus 12. So next, that is 17, right? Okay, the next is we have to check if -1 is greater than equal to 17. So that is false. Okay, as you can see in our example here and in the previous example that we have, okay, by checking the infix expression with the value itself, okay, so as you notice, the previous value that we have is 0. Okay, so if you check, we'll try to go back to our previous example here. Now to get the infix expression, so the result is 0, right? Then on our postfix, converting infix to postfix, so we convert it, and we notice that the conversion, and after that conversion, we evaluate it, then we also notice that the result is also 0. Okay, so which means our solution is correct. Okay, next, so we have show stack operations. Okay, show stack operations. So how do we deal with it? So all I have to do is check or evaluate on the left side, leftmost part of the expression. Okay, so if we have operands, so we'll be pushing it to the stack. Okay, but the operation is push. Okay, push 5, push 2, push 3 into stack. So we have here push 5, push 2, push 3 into stack. Okay, so our stack now would be 5, 2, and 3. As you can see, because 3 was the last part. Okay, last operation. Okay, so next we have the asterisk. So when we encounter an operator, so all you have to do is to evaluate it first. So which means we have to pop 2 operands, 2 values, then evaluate, then push the result. Okay, so as you can see here, we have 2 and 3. Okay, so which means in our stack operation, we pop 2 values and we push 6 into our stack. Okay, so as you can see here. Okay, next, so we have to check the next operator in the expression from the left. So we have the minus. So all we have to do is to pop 2 values from our stack. So we have 6 and 5. Okay, 6 and 5. So we subtract 5 to 6. So the result is -1. So all you have to do is push this back to our stack. Okay, so we have stack operation to pop s. Okay, then we push back the -1 to our stack. The next, so in our expression we have here next operands are 2 or 10 and 2. So all you have to do is push the operand 10 and 2 to our stack. Okay, so we normally do this because every time we encounter operands, okay, so we have to push that in our stack. Then if we encounter operator, so we stop, meaning we have to evaluate it first. Okay, so we pop two values. But in here, so which means as we update our stack, so it shows we have -1 because we push the -1, and we have 10, we push the 10, and because we push 2, so we have 2. Okay, so the next operator is division symbol. So the division symbol would be pop, no? Pop two values in our stack. So we have 10 divided by 2. Okay, so as you can see, 10 divided by 2, the result would be 5, so which means in our stack operation, we pop two values, right? So which means we have pop s, then we push 5, okay? Pop s, then we push 5. The next, we have an operand, so which means we have to push this operand, okay? So next we have push 12, comma s, which means push 12 into stack. So as we update our stack, so which means we have 5, 12, okay? So -1 is still there because it was not popped previously, okay? So the operations was only to pop twice, okay, on the values in our stack, previous stack. Okay, next we have the plus symbol after the 12, so plus. Okay, so which means this is an operator, so we have to pop two values, okay, the 12 and the 5. Then we add, yes, we add this to 5 and 12. So the result is 17, okay? So the next expression or the next operation would be pop s, then we push 17 into our stack. As we update our stack, so we have now -1 and 17. Okay. So next, the last operator that we have is greater than equal. So all you have to do is, again, pop two values. Okay. So -1, 17, -1. Then, so we check is -1 is greater than equal to 17. The result is 0, okay, or false. So which means we pop two values and we push 0 into our stack. So which means the final stack, no, the final stack that we have is 0. Okay, that's it.